Right now, your lungs are doing something so precise that if it failed for just 4 minutes, your brain would begin to die. And the urge that protects you has nothing to do with running out of air. You have held your breath before, maybe in a pool, maybe to see how long you could last, maybe underwater. And you remember the feeling, that building pressure, that desperate need, that moment when your body overruled your mind and forced you to take a breath. You probably thought you were running out of oxygen. You were not. By the end of this video, you will understand exactly what your body detected, how it detected it, and why the signal it sent was physically impossible to ignore. But what your lungs are actually doing in those first 10 seconds, that is not what you were taught. Everything in this video is for educational purposes only. Always talk to your doctor before making any changes to your health or lifestyle. Now, let us start with what your lungs actually are. Most people picture them as two balloons in the chest that inflate and deflate. The reality is far stranger. Each lung is not a hollow bag. It is a tree of hollow passages, branching smaller and smaller, until they end in clusters of tiny air sacs called alveoli. You have approximately 300 million of them. One lung alone contains enough of these sacs that if you unfolded all the surface area flat, it would cover the size of a tennis court. Think of it like this. Your lungs are not two bags. They are two trees, each one ending in 300 million leaves. And those leaves are where every breath your body has ever taken actually happened. Each breath you take pulls air down through the trachea, into the bronchi, through progressively smaller bronchioles, until it reaches those air sacs at the very end. The walls of each air sac are wrapped in a dense network of capillaries, the tiniest blood vessels in your body. Blood flows on one side of the wall, air sits on the other, and through a membrane so thin it barely exists, oxygen passes from the air into the blood, and carbon dioxide passes from the blood into the air to be breathed out. This exchange happens 12 to 20 times per minute, every minute, for your entire life, without conscious thought, without effort, right now. Body Vault AI uses AI-powered 3D visualization to explain what science already knows about the human body. We are here to educate, not prescribe. So what is happening at the level of a single air sac? And why does the body treat rising carbon dioxide as a 5-alarm emergency? Here is what happens the instant you stop breathing. Your lungs do not deflate. Your blood does not suddenly run out of oxygen. In the first 10 seconds of holding your breath, very little changes in your blood chemistry. Your oxygen levels remain almost exactly where they were, but carbon dioxide is already building. Every cell in your body produces carbon dioxide as a waste product of metabolism. It has to go somewhere. Normally, it travels through your blood to your lungs and you breathe it out. But when you stop breathing, it has nowhere to go. So it builds up in your blood, and it builds faster than oxygen depletes. Your body does not start panicking because it is running out of oxygen. It starts panicking because it has too much carbon dioxide. Think of it like this. Imagine a company with an executive at the top who everyone assumes is in charge. And technically they are. But every few seconds, messages are coming up from the operations floor, from the gut, the lungs, the heart, and the executive's decisions are almost entirely based on those incoming reports. The executive is not giving orders into a void. They are responding to what the body's telling them. And here is where the anatomy matters. Your lungs are not one simple system. Under a microscope, each air sac looks like a tiny bubble, a translucent sphere with walls so thin they barely register as solid. The walls of each air sac are wrapped in tiny blood vessels called capillaries. Blood flows on one side. Air sits on the other. Carbon dioxide dissolves into your blood plasma and forms carbonic acid. Your blood becomes more acidic, and that change in chemical balance is precisely what your body detects. Did you know, when you hold your breath, the oxygen in your air sacs does not immediately disappear? In the first 30 seconds, your blood oxygen level barely changes. The gas that triggers the urge to breathe, carbon dioxide, builds up far faster than oxygen depletes. Your body starts panicking about the wrong thing long before the real shortage begins. But here is where the biology gets genuinely surprising, because the organ detecting your carbon dioxide is not your lungs, it is your brain. Deep in your brainstem, specifically in a region called the medulla oblongata, there are clusters of neurons that do one job and one job only. They monitor the chemical composition of your blood. They measure the concentration of carbon dioxide and the pH level of the fluid surrounding the brain. And when carbon dioxide rises beyond a certain threshold, they fire. These are called central chemoreceptors, and they are the most powerful automatic control system in the human body. When they fire, the signal goes directly to the diaphragm, the dome-shaped muscle that sits beneath your lungs and powers every breath you take. The sensors tell the diaphragm to contract, and the diaphragm responds whether you want it to or not. Think of it like this. The sensors are a carbon dioxide alarm hardwired into the oldest part of your brain. When the alarm sounds, the diaphragm does not wait for permission from your conscious mind. It contracts. You breathe. Every time. The same architecture also includes sensors located at the carotid bodies, small clusters of tissue at the fork of the carotid arteries in your neck. These ones monitor both carbon dioxide and oxygen levels. When carbon dioxide is very high or oxygen drops very low, both sets of sensors activate simultaneously. The signal doubles. The urge becomes overwhelming. This is why you cannot hold your breath indefinitely through willpower alone. The sensor signal does not arrive as a polite request. It arrives as a neurological command. And at some threshold, it is simply impossible to override. Did you know your body has a dedicated survival reflex designed specifically for breath holding near water? It is called the mammalian diving reflex. The moment cold water touches your face, your heart rate drops, your blood vessels in your limbs constrict, and blood is rerouted toward your brain and heart. Some research suggests this is why people have survived being submerged for longer than expected, especially children in cold water. There is also something that happens inside the air sacs themselves during breath holding that most people have never heard of. The air sacs do not stay fully inflated. Without the regular bellows action of breathing, they begin to partially collapse. A process called alveoli. Small numbers of air sacs close off temporarily, reducing the surface area available for gas exchange when breathing finally resumes. This is one of the reasons your first breath after holding feels so urgent and so deep. And the signal that fires when those sensors trigger, that is something scientists only fully understood in the last century. So what does this mean for you right now? It means that every time you have held your breath, what you experienced was not a shortage of oxygen. It was your ancient carbon dioxide alarm firing. And the fact that you could not resist it is not a weakness. It is the most finely tuned survival system evolution has ever produced. Your sensors can detect a change in carbon dioxide concentration of less than 1%. The signal they send when they fire is one of the most powerful autonomic drives in the human body, stronger in most people than hunger, thirst, or pain in its ability to override conscious intention. The urge to breathe is not your body telling you that you're running out of oxygen. It is your brainstem detecting rising carbon dioxide and overriding your conscious mind with a survival signal so powerful that almost no one can resist it. You were not struggling for air when you held your breath as a child. You were experiencing one of the most ancient automatic systems in the human nervous system, a system so finely tuned that it can detect a change in carbon dioxide of less than 1%. The brain-breath connection is not willpower versus instinct. It is chemistry running on a timer, right now inside you. Some research suggests that trained freedivers do not have fundamentally different sensors. What they have is a trained tolerance for the discomfort of the carbon dioxide signal. They have learned not to suppress it, but to sit with it without panicking. The alarm is still firing. They have just learned not to run from the room. Did you know the cells lining your air sacs are so thin that if you stretch one flat, it would be just 0.2 micrometers thick? That is 500 times thinner than a human hair. The gas exchange happening across that membrane right now is one of the fastest molecular events in your body. Oxygen and carbon dioxide crossing in under a second. Which brings us to the thing about your own lungs that surprised us most in building this video. Your lungs are not passive bags. They are an active, chemically monitored, neurologically controlled system that has been keeping you alive every second of every day since before you were born. The moment you held your breath as a child and felt that desperate need, you were not weaker than you wanted to be. You were experiencing one of the strongest survival signals the human brain can produce. Your carbon dioxide alarm is running right now. Silent, precise, ready. Next time we go inside your body when it is under pain, and what happens in your nervous system in the first half second after you stub your toe will reframe everything you think you know about where pain actually lives. This is happening inside you right now. Take a breath. Your sensors just approved it. So tell me, what is the longest you have ever held your breath? Give me your honest answer.